So I've finished the job, but you are about to watch a video of me changing the 4 outside corner head bolt holes from M9 to M11 on my N54, and you're going to wonder what you need to order to do the job. So here is all of the parts that I use to do the job. So the first thing that you're going to need to supply yourself is a cordless drill, a decent power one. That's a 18 volt Ryobi. Bit worn, but does the job. Some cutting fluid is also handy. That's a thicker cutting fluid. It's got a consistency like honey. So they're probably 2 items you'll need to have, and then the rest of the items on the cardboard here. So everything left of the line here is part of the N54 kit from Huhn Solutions, the NS300L kit. I'll zoom in on the card there. You can pause it if you want to get their details. So this is actually an N54 kit that they sell for repairing the 10 holes that I didn't touch. The inside 10 holes are already M11, and this is an insert kit for repairing those. But this is what comes in the kit. So first of all, there's this part here which doesn't even get used. So normally I think on Toyotas or something with thicker heads, fatter heads, that goes underneath there, but don't use it for the N54, but it comes with it. It comes with these 2 parts here. You'll watch the video and you'll see how you use all these parts, but it comes with those 2 items there. It comes with the 2 inserts that go in here, a drilling insert and a tapping insert. It comes with this aluminium locating pin, which is used to locate that in the hole. It comes with this 1732 inch drill bit, and it has been customized. The tip has been ground down a bit, but it comes with that drill bit. It comes with 2 custom or special taps that I believe are unique to them, a 3-flute tap and a 4-flute tap. It comes with a little bottle of this Magic Pro Tap cutting fluid, which actually works very well for tapping but not so good for drilling. It's too watery, and hence the thicker stuff that I use over there for drilling is a bit better. Comes with a T-bar handle for tightening the inserts, and it comes with 11 of their inserts. So these are like a Time Sert, but they are much longer, so you get much more thread engagement with them. It comes with 11 of them. For the job that I'm doing, I only used 4, but you can buy extra ones if you want to. They're about $8.50 or $9 US, I think, per extra insert. So that is a whole kit that comes together. The Huhn Solutions kit also comes with a small ruler and a tube of thread locker. The other items I used to drill out the hole in the head from 9mm or from 10mm it is to 11mm was these items here. So this drill guide, which was fantastic, from Big Gator Tools. There's their details there. So it's the Metric V drill guide, and this drill bit, which this happens to be from Sutton Tools. They're readily available in Australia from Bunnings, which is like Lowe's in the US. I'm not sure if they're an international brand, but I don't know if there's anything special about it, except that it is an 11mm drill with a 10mm shank. And I think that's the best type of drill bit to use for the job. So you'll see why in the video. 11mm drill bit, 10mm shank. So they're all the bits and pieces that I use to do the job. Before we get started, I need to point out that I've removed the 2 hollow dowel pins from the block that help locate the head on the block. And they look like this. I didn't have any footage of them, so here's a picture of what they look like in a different BMW engine. The N54 block here is going off to the machine shop tomorrow to be honed and the deck to be faced. Hopefully just a few thou off the deck just to tidy it up. and I am preparing the corner holes for upgraded head studs. So, bit of background: the N54 has 14 head bolts as standard. So there's 7 along here and 7 along the back. The centre ones, or the middle 10, everything except the corners, are these M11 head bolts, and the corners are M9, are a smaller bolt. So if the head's going to lift on an N54, it's most likely going to be the corner ones, which are these M9. So I am upgrading them to M11, but and changing everything out for head studs, ARP head studs, as opposed to head bolts. Now, rather than just drill these out and tap them to M11, I'm going all the way with these inserts. And so this is one of the holes I've already done, and this insert is sometimes referred to as a Time Sert. So it's threaded on the inside to M11. It's got a big fat coarse thread on the outside. It's quite thick, and you increase the size of the hole, the M9 hole, drill it out using this guide here, slides across. I'll put a link in the description to an instructional video that I found useful, but then yeah, that goes, that'll screw all the way down and disappear down inside the hole with some Loctite on it. I'll do that part when I get it back, or after I get it back from the machine shop. So it'll go to the machine shop just with the blank holes there, and the inserts will go in afterwards. But the instructional video I found talks about, measuring bolts and studs and trying to drill down the right depth. However, the kit comes with a drill bit, and it's deliberately, might be able to see there, try and get the camera focused on it. You'll see there the drill bit is deliberately blunted, so that it won't drill any deeper than the hole that's there. So these holes in the corners, from the deck face to the bottom of the hole, are 64 millimeters deep, and that's the 4 corners, and the 10 M11 holes are 74 millimeters deep. So I'm drilling these out all the way to the bottom of the hole, and I'm just hoping that with the new ARP studs, I'm going to get 14 studs, M11 studs, that these corner ones might sit proud 10 millimeters compared to the other ones, but you really can't afford to drill the hole any deeper than the existing hole. So I'm not quite sure in that other video how he ended up with having the head studs at the same height, except that I wondered if he was using the Chrysler head studs as opposed to the N54 ARP head studs. But anyway, this was how I'm doing it, and I'll put a link in the description to that video. This kit, it's quite often referred to as Time Serts, but they're not Time Serts. They're called NS300L inserts, and they come from this company, Huhn Solutions, Huhn Solutions.com. And in fact, this kit that I bought is the kit for BMW N54 head bolts. So it comes with 10 of these inserts for repairing these 10 holes, the middle ones. But I'm keeping them threaded into the aluminium, and I'm doing the corners. There is a disclaimer here in red that talks about if you want to upgrade the M9 to M11, you do so at your own risk. This is where the N54 head is most likely to lift from, is these corners. And so with these inserts, I should be able to get plenty of clamping force in the corners and prevent the head from lifting. This one is the next one I'm going to do, and this one's probably the riskiest hole because it's got the least amount of meat on it. All of these other ones, they're close to the edge on one side, but they've got heaps of meat around the back of them. All the other 4 corners, this one's already been done. You see lots of meat around the back of them. But this one here's the next one to be done, and this one's probably the riskiest. It'll be interesting to see what it looks like afterwards. Got the jig set up, made sure everything's nice and clean afterwards. You get, bucket loads of these chips go flying everywhere and come out of this process. So every time you clamp this thing down, you want to recheck that you haven't got any chips caught under these guides. So there's a drill guide inserted in here, so the internal diameter of that matches the outside diameter of the drill, and I've got a head bolt in there, and I put this in, line that roughly over the hole. There it is. So I line that roughly over the hole, chuck that in, hold that down really hard. I use my left hand to do that. With my right hand, I'm going to tighten up this head bolt while putting a lot of force down on that, which will centre this drill guide directly over the centre of that hole. Head bolt here is tight while I was holding down on that, so that out. Might try and look down there, but focus the camera. There we go. So it's nice and centered there. So it's ready to drill. You got to make sure that you don't drill and tap the oil galleries here. So there's an oil gallery here and an oil gallery there. I almost had a heart attack when I started drilling the first one over here, and then saw the hole and thought, oh no, I'm not in the head bolt hole. But yeah, these ones are oil galleries. So that one's ready to drill. That's nice and tight. Now I'll put some cutting fluid on the end of the drill and run it down through here, and basically just drill till it bottoms out. About 4 to 6 times during that drilling process. I stop, pull the drill bit out, clean all the chips off of it, and then put it back in. You need to do that as regularly as possible, at least 4 or 6 times during the drilling process. This one's bottomed out, so you'll know when the drill bottoms out, just stops biting and going in further. It's probably safe to have a measurement, but for me, I recognise it's basically where this shank changes to the drill size, just a few millimetres there. It's just sitting there. You see that grey colour to the cutting edge there. When it's sitting like that, then it's all the way in, at least for the drill bits that are shipping with it at the moment. That's bottoming out on the bottom of the hole. Try and pull that out. There we go. And so that's chips, and this chips and shit goes everywhere. But that's now done. So now undo this little thumb screw on the back. I've done it up just with a pair of pliers gently, but undo that. Take that guide out, and I'll put the next guide in. So I'll clean it up with this one here, the tapping guide. You do not want to remove the head bolt yet. That needs to stay there, and I'm just going to take that drilling guide out, put the tapping guide in, and then the first tap that we need to use is the 3-flute one that comes in the kit. So look on the end there, it's sort of triangular shape, 3-flute one, that's the main tap. So it comes with that tap as the main tap to run down, and then a bit of a, well, I wouldn't call it a bottoming tap, but close to a bottoming tap, intermediate tap maybe, and that's a 4-flute tap, and they both come in the kit. And it even come with this Magic Pro Tap cutting fluid, which I've been using with the taps. It's a lot thinner than my cutting fluid that I normally use, this stuff here. This stuff's like honey, but this other stuff is really runny, but yeah, it does seem to work very well. So I'll start by running that tap in, and I've found that I'm just using an 11mm socket. I think 7/16 is the other size here. The tap just goes in that on a 1/2-inch drive with a T-bar handle, and to run the tap down in. So I've gone in with this tap, keeping the oil onto it, lots of oil, cutting fluid, and I've gone in basically until the T-bar handle here starts touching on there. Then I know it's time to remove this jig now. It'll come off, it won't go back on, because I'm already, basically this is drilled all the way, or this is tapped all the way in, probably till about up there somewhere. So it's plenty started enough that it doesn't need the guide anymore. Probably a good time to point out as I remove this that you use the M11 bolt hole next door to the M9 that you're drilling out. So the tool could probably reach across here from one M9 hole to another, but I would recommend using the M11 holes to do the M9. So yeah, it's obviously screwed in with it to an M11 here. To do this M9, I had it screwed into that one there, that M11 to do that M9. Down here, that M11 to do that M9, and this will be my last one to do, and I'll screw it into that M11 hole to do that M9, and that way I'm always just using the original head studs in a hole that they were destined to be in anyway. And inevitably you have to use compressed air to clean the hole out, so now I'm tapped about probably almost halfway down there, but I've cleaned the hole out with some compressed air. I might even put some brake cleaner in it, and then I'll put my same triple flute tap back in, a bit of cutting fluid on it, and now continue tapping that hole without the guide in the way. And it's pretty much bottomed out down the bottom of that hole. I'm unwinding it now, but my tapping process, what I learnt at trade school, which I continue to this day, is to, as I'm tapping in, I will turn this 180 to 360 degrees, so no more than that, and then I'll always back it off about just over 90 degrees to break the chip off that's forming inside of there. So you're constantly going in about one or two turns of this, or two half turns, I guess, 360 degrees, and then backing out about 90 degrees to break the chip off, and then going again and pulling it out every now and again, adding some more that cutting fluid. And I'm being very generous with the cutting fluid. When the flutes were showing down there, so now I'm back out far enough that the flutes have started showing. While they're showing, I'm pouring or dribbling a couple of drops of oil down those flute channels there as I was going in as well. Cleaned the hole out with brake fluid and blown it out with compressed air. Now I'll screw this triple flute one back in one last time and just make sure it's bottoming out, but try and go all the way in by hand, just to make sure that there's no burrs forming. Tap all the way in and it bottoms out. It just goes hard all of a sudden, so you know you're at the bottom. And so that tap will now come out, and I'll clean this other tap up, the 4 flute one, and that'll go in, and we'll get maybe, I think, about 1 or 2 turns out of this, just to cut the threads down a little bit lower. And this 4 flute finishing tap has gone in, and it did another 1.5 to 1 3/4 turns before it also bottomed out. Now I'm just removing that by hand, and then I will clean the hole out with some brake cleaner and compressed air. The hole's all cleaned out. Checked it visually, nice and clean. Got myself an insert, made sure it was nice and clean. There's a couple of drops of oil on it so it goes in easy, and I'll just test fit it, so we're not putting Loctite on them yet because it's going off to the machine shop. But I'll just screw that in, and then that's the little laser cut little T-handle they provide that drops into these little slots that will screw it down all the way. So I'll just test fit it. If it binds up at all, I'll take it out, run the tap back through, and just make sure this goes in nice and easy. And the insert's down till it bottoms out, and I'm finding that using the vernier calipers, it's about 13 to 14 millimeters, 13.5 to 14 millimeters from the deck face down to the top of the insert. To the top edge of the insert, and that's where they bottom out. So I know that I'm getting them all equal, they're all going down the same mount, so that's the reference. Now as I remove that insert, remembering that it's going off to the machine shop, so these will go back in after I get it back, so they'll clean the block, dip it, soda blast it, deck the face, hone the cylinders, and then when it comes back I'll put these inserts in. But now you get an idea maybe of how much extra meat it used, and yeah, this is probably the as fine as I'd want to cut it, but there's still significant amount of, let's finish taking that out. Yeah, there's still significant amount of meat there for it to grab hold of, so I really don't think that's that this insert's gonna pull out of the alloy block there. I think there's plenty enough, and remembering it's got these it's thin through both sides there, but it's not thin through the sides here, and these are steel inserts, not alloy inserts, so yeah, confident that it's not going to pull out of there. And just to be clear, this is the top of the insert, the little slots in the side of it, and you can see the internal thread starts, it's about 10 millimeters down. I can measure it, but it's about 10-12 millimeters down. The internal thread starts from the top, but at the bottom the internal thread goes all the way to the bottom. So I finished this off last night, and I've come out this morning to check my work and run a few tests. So the first thing that I've done, cleaned all the holes out again, filled them up with brake cleaner, and just watched to see if the brake cleaner level drops or any faster than the evaporation rate, but that it doesn't drop, indicating that I haven't breached the block. For example, from our new larger hole to this hole here, that there's no other holes other than the single hole in the top here. And in all cases, they're all good. Also blasting them out with compressed air. I'm actively looking for anywhere else that the air is escaping, and it hasn't breached the block anywhere else that I can see. Also wanted to check that the head gasket is still going to seal. So we've reduced the amount of surface area here between the hole and the water jacket, and just wanted to check each of those, and I'm pretty confident the head gasket's still going to seal, because you can see the darker area there closer to the water jacket, that's where the head gasket deposit has been left, that's where it was sealing. And I've still got a ring of clean aluminium face on the inside of that towards the hole, which means that the sealing is happening before it gets to the hole. So that's the same on all of these. Just show you those. So in all cases, there's a clean little strip of aluminium face between where it seals, or between the water jacket and the hole, and same there. The next thing that I did was put an insert, using the same insert, but ran it down to the bottom of each hole, and then taken a measurement, and should still be on the vernier. That one there was 14.6 millimeters. This one was 14.6 also. This one was 14.3, and this one was 14.5. So the distance I'm measuring there is from the face of the block to the top edge of the insert. So 14.5 millimeters, plus or minus 0.1 or 0.2 of a millimeter. Happy with that accuracy and consistency. Now, the next thing to note is that these inserts, they bottom out in the bottom of the hole, but the bolt can actually still travel through. It can keep screwing through. So it does actually, I think, from what my measurements, it actually goes through the bolt, or in my case it's the head bolt, but I will be using studs. The threaded part does protrude slightly beneath it. Now, so I wind that off, you'll see there is internal threads all the way to the bottom, but there isn't all the way at the top. It'll be easier just to grab a new one here. So that's the bottom there. The internal threads run all the way to the bottom. On the top though, you note the top has these little slots. The threaded part starts about 10 or 12 millimeters down. So the thread engagement area, if the stud I'm using bottoms out, it means that I'm using all of the available, or engaging all of the available internal threads of these inserts. So although I expect this stud is going to sit 10 millimeters higher than the stud in this hole, my only concern is whether that's going to have any impact inside of the head. I'll still have the same amount of engagement, and I'll be confident this one's going to be stronger because it is using the steel insert. but this one is going to sit up 10 millimeters higher. I haven't got the head here, it's off at the machine shop already, so I can't see what impact that stud being 10 millimeters higher inside of the head is going to do. But if it is a problem, then I'll just use a cold saw, like a hacksaw, and just cut a portion off the top of it if I need to get them all the same length, if that is critical. So that's my thoughts and comments to finish this off. So the story doesn't end there. I went to the machine shop, race engineering shop, to drop off the block to get the work done on that. And as it turns out, they were about to start work on the head, but they hadn't yet. So we got the head and the block together, and I discussed a few concerns with the engineering company. And I'll come to those in a second. Before I do, let's just address the other query I had, was whether the studs in the corners sticking up 10 millimeters higher than elsewhere is going to be a problem, if it's going to be a clearance issue. And I can see that obviously that's one of the M9s stuck in that hole in the corner. I've just set a valve spring there. I'll sit something like that. Yeah, there's not going to be any clearance issues. It won't hurt if that sticks up a centimetre higher, I suspect, than the other ones. And so I really don't think that's going to be an issue with the depth that I drilled those corner holes. So anyway, we'll put that aside. Just move that out of the way. So the concern that I had was that on the block there are two locating dowels, and they're in the corners, diagonally opposite corners. I think it's that corner and that corner, or that one and that one. Nonetheless, that's what actually locates the head gasket and the head on the block. And talking with the engineering shop, my concern is that this M11 bolt, which is going to be replaced with a stud, is very sloppy in its hole, along with the other 9 of those in the middle there. So these are M11, and the hole is just over 12 millimeters, somewhere between 12 and 12 and a half. I think it's probably about 12.1, 12.2 millimeters. So there's quite a bit of free play there, which would allow the head to move laterally, as well as the head gasket. So I'm left with these holes. Now on the M9s, as they are from factory, the hole is actually just under 10 millimeters. I think it's probably 9.8 or 9.9 millimeters, and it has an M9 in it. So once again, there's half a millimeter of play each way, or plus or minus a half or a 1 millimeter movement of play. But here's my option, or my opportunity, to use these holes as the new locators. So hopefully drilling the block with those inserts, that everything was perfectly centered. I need to drill these holes out to exactly 11 millimeters, and then the 4 corners will become the locating points for the head gasket and the head, so that it can't move laterally before we bolt it down. So yeah, I'm going to use a drill guide. Got one of these big gator drill guides. Finally got it. I ordered it a while ago, and yeah, I've realised it's going to work well. First of all, I'm going to say that this handiwork of all this silicone crap on here is the previous owner, along with all the screwdriver imprints and scratches they put in it. So geez, I wish people would learn how to change a valve cover gasket. There was silicone all over everything. And scratch marks everywhere. That was the previous owner. I've just got to clean up the mess. But yeah, this drill guide, I'll use this. Right, I'm going to stop this here, and I'm not going to bore you with my theories, because I ended up doing something slightly differently. Still using the drill guide. You're going to see what that is in a minute. Let's move on. Now, I was concerned about the valve guides. I'll try and put the camera here. Concerned about these valve guides being worn, and I asked the engine builder or head reconditioner to have a look at it, and they've taken some measurements, and yeah, they've concluded that the exhaust valve, which is a smaller one here, is worn excessively, and the valve guides need to be replaced, but that the inlet side isn't. So apparently that's normal for nearly every engine, is that the exhaust exhaust valve guides wear faster or more than the inlet side, so I'm going to look to replace them just as a reference to show you how much movement there is compared between them. I don't have the tool that goes up inside the hole and measures the bore of the hole. It's a special I can't remember what they're called, a little ball in a thing which you twist and turn and then measure it with a vernier or a micrometer. I don't have that tool, so this is the next best thing I can do, is pull the valve out the same distance, rest this on the face there, and square with the valve there and move that. So yeah, I've worked out that there is about 15 to 16 thou of side play in that exhaust valve, and on the inlet side, measuring the same way. If I can get the valve to poke out, there it is. Hold that there and square of the valve going in and out. There's, try and hold it steady, it's about 6 thou, maybe 8 thou, 6 or 7 thou of movement there on the inlet side. And so just for reference as well, how much move, if you're going to try and take this measurement in that position, let me just grab the camera so the valve is in the position that I'm measuring it, to show you how far through it is. So it's that bottom one there. You can see there that it's about 4 or 5 millimeters from the bottom collet ring that's groove in the valve stem there. So that's how far through it is. And pull on it now and pull it back. But yeah, that one's very little movement, but on the exhaust side here, it's quite a bit of movement. So the exhaust valve guides are going to be replaced, and then cut new seats and in for the valves as well. I've taken measurements of most of the holes or valve guides along here, and they're all pretty consistent. On the exhaust side, it's between, I think the best was 15 or 16 thou and the worst was 18 or 19 thou. And on the inlet side, they are between 4 to 7 thousandths of an inch. So yeah, quite a bit of difference, but definitely happy to see the valve guides on the exhaust side get replaced. They are pressed in and out, so I think they press them out from this side, so they'll go in there, press them out so they pop out the top. They're a brass sort of fitting. A couple of different suppliers of those. I found some, but the engine builder has their own source for N54, and apparently it's not uncommon to be replaced, and so they will source those and install them. I believe, yeah, once they've pushed the old one out, they put the block in an oven and heat, or sorry, not the block, the head in an oven and heat it up. And then they put the valve guides in the freezer and then knock them in quickly, and they're an interference fit. And contemplated how I'm going to drill these out to 11 mil and make sure that they're perfectly centered, or as centered as best I can. And the way I'm going to do it is, so here I'm about to go again on my theory of how to drill these holes out. I'm not going to bore you because, as I said, I changed the process. But what you do need to know is that these holes, this is one of the holes that has the dowel location normally on it, which now the dowels are gone. The dowels are gone out of the block because we drilled those holes out. But there's a larger hole at the bottom of here where the dowel normally locates, and then it goes to a 10 millimeter hole, and right at the top it changes back to about 9.5 millimeters. So most of the hole there is 10 millimeters in diameter. And so I'm just messing around with drill bits here of different sizes to work out what size, and I've worked out that I can put that hole is 10 millimeter. And let's stop that there and go straight to the process. change of plans. So I probably should have had a stronger coffee, because this is a much better idea. So rather than drilling my 11mm hole from the top of the head down, I want to drill it from the bottom of the head up. Head's obviously upside down. So, and as it turns out, this is my 11mm drill with a 10mm shank on it. 11mm hole there, slide that down through there, and it centres on my 10mm hole in the head, and the 11mm centres in there, and this ends up at the 14mm hole on this drill gator guide, and with plenty of play. So I won't undo the nut, but there's 2mm with the M9 in there. There's heaps of play in there, so the position of that bolt isn't interfering with the position of the guide. So with that sitting there, I'm going to now tighten this up quite tight, at least try and tighten an M10 nut up on the M9. If that doesn't work, I've found out that I can't use an M12 on the M11, so I'll just use an M10 bolt through here and tighten that up nice and tight with the drill bit centered, and then I'll run the drill bit from this way, turn that around and drill through there. So I never needed to do that because we're just going to drill the hole out to 11mm this way anyway. And I much prefer using the face of the cylinder head as the reference, because this is the critical side. This is the side where we want the cylinder head to align, and so drilling from this side means that if there's any small error at this end, it's going to be magnified at the other end, and vice versa. If I did it the other way, any small error that I had drilling from the top down would have been magnified, and I would have had a bigger error here, which could have moved the position of the head or interfered and made the head gasket or head not align properly. So drilling from this side, much better idea. So summarise, this is all you need to do. You don't need to run the 10mm bit through at all. Just for reference, so this is an 11. We're drilling an 11mm hole here, but just for reference, the M11 bolts are not actually M11. This is turned off, but I'll turn it on. There's the measurement I took. So this M11 head bolt, and should be the same size as the head stud, is actually got a diameter of 10.83mm. So it's about, so let's say 0.2 of a millimeter difference between the head bolt and the hole I'm drilling. So I'm going to have plus or minus 0.1 millimeters of movement to play with if I'm slightly out of a line. And for those in the imperial world, 0.1 of a millimeter is the thickness of a human hair or a bee's dick. I've never measured the bee's dick, but that's apparently what a bee's dick measures. Actually, I need to clarify that actually the ARP studs, I don't have them yet, but if they're anything like this bolt, the threaded part's 10.83, but the shank part here, or at least on the stock M11 bolts, is actually just over 10mm. And so I think looking at the photos of the ARP, they don't look any worse than this. They're not like significantly narrower through the middle. So maybe I'll have a little bit more free play here in my 11mm hole. But what I can always do is just use one of my original head bolts down through the hole, which has got much longer thread on it, and just use that in the corners to get the alignment of the head and the head gasket, while I perhaps start just doing the initial torquing on some of the center ones, which have got a lot more play. Then pull these ones out, put my ARP studs in, and I'll be good to go. So that's my backup plan if I need it. But yes, ready to drill. That's worked very well, very happy with it. As I was drilling it, I could look down the hole and see like a little step that was moving down as I drilled down further, and it was equal on each side. So very confident that it is drilled accurately and centered this new 11mm hole on where the old hole was, and cleaned it out with a bit of brake cleaner, and it's a nice solid fit there. Very tight fit with the 11mm drill bit. So yeah, very happy with that. The only thing is that the drill bit, typical drill bit, it's got a fairly sharp angle on it, and it needs to be a bit shallower because it really bites and pulls in hard. So I've never been good at sharpening or adjusting drill bit angles, so might investigate if there's anybody that I can take this to and get a shallower angle put on it, just so it doesn't pull through so hard. Might be using a cordless drill is okay, but remember we're using this guide to centre it. I could put it on a drill press, but then I risk the drill press not being perfectly square with everything and messing with it. So I think I'll try and see if we can get that angle changed, but if I can't, then I'll just keep doing them. It is working quite well, just time consuming. Drill guide removed, and I did that up fairly firm, not super tight, definitely not to the full tension that well an M10 nut will take on an M9 bolt, but I did it up fairly firm. But yeah, even with it firm, there's no imprint left anywhere here from the bottom of the drill guide, so that was a concern of doing that up too tight, but I did it up fairly firm, or very firm enough that this never moved during the drilling process. And yeah, it hasn't damaged the face, but of course, yeah, always better. I'm glad I'm doing this before they've refaced this cylinder head, because if I did mark it, then I'd have to take it back and get it done again. Called a few drill sharpening services and explained to them my problem. I thought changing the angle here would help resolve it, making that a shallow angle, effectively almost like a flat drill bit, but they tell me no, it doesn't. It's the angle of these flutes. So this angle here is very steep, and that's what's really wanting it to pull in, and that sort of makes sense. So changing the angle of the tip, they said, won't really make any difference. So we'll have to continue with it like that. It is doing a good job, or at least it's yeah, leaving a nice hole. Looking down there, you can probably see there, it's a little bit rough, but it is, yeah, it's not oversized or anything. That's a nice tight fit in there. So we'll go ahead and do the other 3 holes that way. All finished with the 11mm drill out, so the holes look a bit nicer from this side. There's one. This one I've got the bolt in there just to show how much wiggle that moves a few thou, so try and centre on it. So that's going to be a nice fit, but yeah, the holes look a bit neater and cleaner from this side, but yeah, definitely gonna do the job, and I'm confident that they're centered properly. So now the drill really was biting. I did find that, interestingly, this heavier cutting fluid, this like a honey sort of consistency, worked better than the light stuff, this watery stuff that came from Huhn Solutions with those NS300L inserts. This is a bit too watery, and for some reason when I tried to use this in the hole, it really bit hard and pulled through hard. So yeah, the drill bits, yeah, this is really the only drill bit you need to do the job, as I said. So 10mm shank, 11mm drill, and that allowed me to centre it and do everything I needed to do. Just to make it clear, my 10mm drill bit has a 10mm shank. The 10.5 has a 10.5mm shank. So was hoping that maybe my 10.5mm drill bit had a 10mm shank, and then I could have drilled them out to 10.5 to start with, and then out to 11, and that maybe would have made it a bit easier with the drill not biting so hard. But anyway, yeah, I was only able to use this drill with a 10mm shank, 11mm drill bit. And this is the drill guide that I'd strongly recommend if you're doing this job. So it's from Big Gator Tools, and I believe they have the patent on this sort of setup. But their metric V drill guide has the exact right spacing between the 14mm hole to bolt it down and the position of the 11mm hole there. So yeah, that's another tool that's needed to do the job. Can't find my deburring or chamfer bit, but it's just a little bit of a burr on the top of the head where the drills pass through. So I just used the biggest regular drill bit I had, a 13mm, just by hand, just turning it by hand, just took the burr off of each of the edges of the new 11mm holes. I'm going to wrap it up there, and if I find that any of the work I've done causes me problems in the future or in the next steps, then I'll put some notes in the description of this video below. That'll happen the next few weeks or the next month when I start assembling it. And if it's really bad, then I'll make another video of what I did to rectify it. But I really don't think I'm going to have any trouble, and I'm really happy with how this has all gone together. I shared the details of the tools. This is the insert kit again, so there's the details there. It's Huhn Solutions, so Norm Huhn, and he was very helpful when I contacted him. And he does that N54 kit with the 10 inserts to do the 10 regular holes. But so I bought it with extra inserts anyway, in case I wanted to do all of these. But in the meantime, I'd had some communications with a US-based engine builder who is renowned for N54 1,000 horsepower builds, and I'll leave him anonymous, but let's just say he's probably the most trusted builder of N54s over 1,000 horsepower, and yeah, he indicated that he only recommended doing the corners with these inserts, upgrading the corners to M11 using these NS300L inserts. So they're not a Time Sert. Time Sert is a brand, but they are similar to a Time Sert, but a lot stronger. So I'll leave the video there, and yeah, let me know in the comments if you got any questions or queries or suggestions on maybe how I could have done it better.